So this talk would be more general than just about social leisure, because the story started long ago. And here I cannot discuss all my studies which led me to this social leisure model. Or maybe in a future talk at your department I can do this, but now I just make few steps. So there is quantum-like cognition and irrationality of human behavior. So this was our main interest. And what we were interested in usual decision theory and in paradoxes of this theory. And this led us to social leisure model of crowd behavior. First of all, I would like to make decrypting of the word quantum-like. So, of course, there are many works on quantum cognition, but quantum-like just means that we borrowed mathematical apparatus and methodology of quantum physics, but we don't claim for any physical quantum process in brain or anywhere else. So part one, it would be just few words. Of course, as I told, there is quantum brain project. This is Stuart Hamerov, who really claims that brain in microtubulus, there are superpositions, entanglement, and so on, and therefore human cognition should be described by quantum physics, by quantum model, not classical. Some people are very against this quantum brain project. I'm not. For me, I am neutral. For me, it does not play any role. Is Stuart Hamerov right or not? For us, brain is black box, and we claim that this brain black box process information which cannot be described by classical probability and hence by classical information theory. So this is starting point. How we came to this idea that brain is non-classical? So Hamerov used quantum physics and so on. For us, even classical brain with classical waves is okay, it's no problem. For us, is that information is processed non-classically. Here we are more or less on the same way as it was in quantum physics. Quantum physics started with just experimental data, which was not so well described by classical statistical physics, for example, black body radiation and so on. Here in psychology, cognitive science, game science, decision-making, social science, economy, finance, and even in political studies, we have a lot of data, statistical data, which maybe we don't claim that it's in principle cannot be described classically, but at least maybe quantum description is more natural. Quantum description is more natural. I wrote a book quite long ago, 2010, and what was also big support for all this project, that Jerome Bussimer, who was without any quantum, he was very big name in cognitive science and psychology. By himself, he came to the same ideas, that quantum formalism can be used to describe human psychology. And then I also cooperated a lot with Emmanuel Haven, where we started to study social science and so on, and then even finances. Yeah. So, what is one of the points to connect with usual psychology, with usual decision making? These researchers, they had problems from very first days of mathematical formalization of decision theory. For example, from the works of von Neumann and expected utility theory and so on. They have problems with probability fallacies, irrational behavior of decision makers, and also many paradoxes of decision theory. For example, Ellsberg paradox, Elias paradox. More or less the whole development of decision theory was they make some mathematical model. It's much to some data, but then people found some new paradoxical situation when model does not work, and model is improved. In particular, Kahneman, he got Nobel Prize precisely for modification of decision theory, modifications for decision theory. So they, with Tversky and also Shafir, they are psychologists and maybe behavioral economics, they by themselves started to see such data, which is collected from decision makers. It does not match classical probability theory. And they found many such strange situations. And it was in 70s, long ago, before we even started to go in this area of research. And they asked these questions. So they really were disappointed how badly worked classical probability theory in statistics, behavioral economics, behavioral finances, and so on. And more or less, the intention was abandon statistical and probabilistic description. Roughly speaking, the idea was that all this, for example, social opinion polls, that more or less they're meaningless because the data which is produced by them can be interpreted in this way or this way, and can lead to probability fallacies and so on. They were more in the heuristics, in the favor of heuristics and individual case studies. So maybe the problem is not with probability, because they were, for example, I spoke with Tversky, and he was more or less angry against foundations of probability generally. But maybe the problem is not in P, not in probability, but in C, that it is classical probability. That it is model what was established by Kolmogorov and use measure theoretical approach. So maybe if we started to use quantum probability instead of heuristic of Tversky and Kahneman, maybe we can resolve all these paradoxes. So this was the idea. And this is classical probability theory. Quantum probability. Quantum probability is not calculus of probabilities, but calculus of probability amplitudes. And what is the main thing which we can test in experiments? In real experiment with decision makers and so on, so that the formula, the additivity of probability is validated. There is always, in many, not always, but in many experiments on decision making and psychological effects, there is additional term. So this is classical additivity. An additional term which I call interference term. And this interference term appears very easily if we use this formula, Born rule. From Born rule, it appears very simply. And maybe now I should jump to laser, because otherwise we will not tell anything. But I would like to make point to Richard Feynman, who is one of the most famous scientists of 20th, physicists of 20th century. And he pointed, very often physicists are interested in physics, but Feynman also, he was physicist. He pointed that one of the main discoveries of quantum mechanics was fundamental discovery that in nature, at least on the micro level for microsystem, the laws of combining of probabilities are not the same as in classical probability theory of Laplace. Feynman did not know about Kolmogorov, Kolmogorov probability, but more or less he spoke about violation of the rule of combination of probability. So precisely about this rule, So, and for him, this violation of this rule appears of interference term was one of the main distinguishing features of quantum theory, of quantum formalism. Of course, we cannot borrow, for example, to social science, to biology, physical aspects of quantum mechanics. As, of course, Penrose and Khamerov, they try to do this. But if we read this citation from Feynman, it looks that if quantum mechanics about new probability, maybe we can borrow this new probability, I call it quantum probability, and apply to other strange things which are not explained by classical probability. So what is also interesting is that this same ideology can be used in biology, up to molecular biology, and was very big project in Japan. And for example, Ichiro Yamada, he is very famous in genetics, and there were real experiments with cells and so on. And of course, each cell is also very complex system. Each cell is very complex decision maker. And cells are also do decisions with this interference which I showed you. Maybe the last, I should go to laser. So, but nevertheless, I told the brain is black box, and we're not interested where does this violation of classical probability come from. Maybe we can tell, nevertheless, there is some idea behind why we have this, what I call quantum-like paradigm, and mathematical formalism of quantum theory should be used not only for microsystems, but for all context-sensitive systems, systems which react very sensitively to context change. So, for example, to human. So, and what guys should do if they're so sensitive to context? For these guys, it is very useful not to resolve ambiguity, but process ambiguities without resolution. And this processing of ambiguities is processing of superpositions. And superpositions are described by quantum theory. Now I want to jump to laser. I think it's page 43. Yeah. Just one maybe step. Yeah. Now we go to this part. It was maybe after 15 years of my work in quantum-like decision-making and biology. Over last years, and it was especially visible before pandemic and so on, and even during pandemic, and even nowadays, we see that human society has been shaken by high amplitude coherent information waves. So these were waves which happen in information space. Information space is basic in this consideration, that nowadays a lot happen not in physical space, but in this space of internet and social networks. These waves carry enormous social energy. They can be considered, they can be very often destructive. We can call them information on social tsunami. Here, first time appears the notion of social energy. Social energy would be the basic notion of social laser theory. Of course, one can tell that, oh, this is speculation, where have you seen social energy? But nevertheless, what are the main distinguishing properties of these waves? High amplitudes, so these social disturbances are of very high amplitude. Coherence, so these are not just people do the actions, social actions in the same, so to say, in the same direction. And short time required for their generation. So the wave can go up very quickly, and at the same time, very quick relaxation. So roughly speaking, generation of single social spikes. But of course, even if this duration of this spike is short, they can be very destructive. Yeah. So there are a few, just a few photos from different social protests, and there was a lot of study about them, this protest in social and political sciences, especially this still hot topic, which is called color revolutions. So in many countries, especially on the post-Soviet territory, but not only. The first color revolution was at the Philippines, at the Philippines. And yeah, so many such color revolutions. The idea, how can we model them? How we can model all these social spikes? And we can tell that maybe we can borrow again from quantum formalism laser model and speak about social laser. Of course, it is in some way one can say it's metaphor, but I put more weight to this, not just metaphor, because we can develop theory beyond it. Coordinated social actions considered very broadly. It's not only color revolutions or mass protests as we consider it in many countries. Protests in USA were these protests when Floyd was killed, I think in New York or Boston. But it can be also collective decisions. For example, decision for vaccination. In Sweden, it was really in the form of spike, because Sweden was very different from all other countries of the world. So we did not have masks, we did not have isolation, anything. We were more or less usual life. And then mass media, state authorities, medical authorities started very powerful campaign for vaccination, and it worked very well. So 90–80% of population went for vaccination. So in 2 words, conventional laser, how conventional laser work? There are 2 stages. First stage is energy pumping and approaching population inversion. So there is active medium, huge ensemble of atoms. Energy, this is usual laser, energy is pumped in this gain medium. Typically, it's electromagnetic field. Atoms, we consider the simplest model when atoms are 2 levels, ground and excited state. Of course, it is not easy to make a usual physical laser with 2 levels. One needs at least 3 levels to get good physical laser. So, pumping with photons, unexcited into excited, and of course, at any moment, atom can make spontaneous emission and emit photon. But if pumping is sufficiently strong, higher than some threshold, we can approach so-called population inversion, when the majority of atoms become excited. So this is gain medium where majority of atoms are excited. Then the second stage, stimulated emission. So in this emission is injected a bunch of photons, which stimulate emission of photons from excited atoms. So this is a process described by quantum field theory. So it in textbooks is typically very primitive, that if you have excited atom and there is flying photon in this direction, so if they interact, atom also emit photon in the same direction. So then there are 2 photons, they interact with 2 atoms, each of them emit photon in the same direction, now there are 4, so this is cascade process. No, in the primitive level, this is this picture, but generally it is quantum field picture, so there should be sufficiently high density of photons around atom, and then this emit. In any event, cascade process is generated. But it's not enough. Because this flow, coherent flow going in the same direction of photons, they pass this gain medium very quickly, and they could not interact with all atoms. So the output is not so strong. Therefore, there is resonator. They are typically 2 mirrors. I think I have picture. There are 2 mirrors, and this beam of photons is going this direction and this direction, and here is gain medium. So my co-authors were from Paris, and this is a French picture. after few such iterations, the beam becomes very strong, and then this semi-reflexive mirror, and beam goes out, and beam goes out. The social laser resonator, this cavity, optical cavity, it is also important to make the beam more coherent. So if some photon goes is spontaneously emitted, and it's come not along this axis, but under some angle, it is reflected and go out from this social resonator. Now, social laser theory, we try to copy the physical laser, also 2 stages. There's human gain medium and the pumping of social energy. We shall be back to social energy, which is the main notion. And then when population inversion is achieved, when the majority in this group of people are excited, then stimulated emission. So a bunch of social photons, we can say, or quanta of social energy, coherent quanta of social energy, is injected in this gain medium and started the cascade process of stimulated emission. So this is my book. Now, as I told, the main is notion of social energy. If one accepts this notion, you can buy the whole theory of social laser. But if you from the beginning tell, look, it's too speculative, it's then without the notion of social energy, it's not easy to proceed. So, of course, many people in psychology discuss the notion of psychic, mental, social energy. To describe the process of exchange of such, I can say, really psychic energy is very difficult. And here it is crucial that laser is quantum thing. So energy has the quantum operational description, even in quantum physics. So we cannot speak that atom or photon has some concrete energy. We just have operator of energy, which is observable, and we can just collect statistics. We can collect statistics. So there is no more mystics behind psychic, mental, and social energy. So there is just operational definition. So we can measure that some social atom or a person is excited or not excited. For example, to make just to scale and to make measurement by questions. Now, beside of social energy, we need something similar to electromagnetic field, which is used for pumping of energy into gain medium. So these are, but again, photons are not particles, in fact. If you consider photons from the viewpoint of quantum field theory, photons are just excitations of field. So we need some field. And this field would be information field. Which messages, communications, news, and so on, we consider as carriers of social energy. Of course, we should not, here again, it's good that we have quantum operational description. So we need not imagine information field as some wave going in our space. It's not just radio waves or electromagnetic waves. So quantum field description is just formal mathematical description with operators of creation and annihilation. So we can also do this with operator of creation of social energy and operator of annihilation of social energy. Yeah. Social atoms. And so to get here we should look to thermodynamics and how quantum or quantum statistical mechanics, how people derive quantum statistics. If we forget about everything, and there is a very nice book of Schrödinger, which is called Statistical mechanics, the very small book of Schrödinger. And Schrödinger told to get quantum statistics, both Einstein, Fermi, Dirac, of course, there could be also parastatistics. One can use only indistinguishability of systems. If systems are indistinguishable, then you can get one of these three statistics. So, to get, if you proceed in physical framework where we consider energy distribution and so on, it is more difficult. But in distinguishability, we can move very easily to social science, to cognitive science. So we want that humans participating in social leisure would lose their individuality. Of course, they could not be totally identical as quantum systems, yes? But up to this process, of course, everybody has his name and so on. But when they participate, for example, in color revolution, in their actions in this context, they can be considered as indistinguishable. Of course, one can tell, look, here's huge difference. In quantum physics, we don't have hidden variables. And here, it looks that you still have hidden variables. The guys are indistinguishable, but the hidden variables, if you know these hidden variables, we can distinguish them. I think the crucial point is contextuality. So all these no-go theorems, Bell theorem, von Neumann, and so on, which told us there is no hidden variables, they are uncontextual. So contextual hidden variables exist. And as we told, all the social things or social situations are contextual. So this is, in one context, I show my passport, and in other context, I don't show I try not show my passport. So this is, then in one context, I'm distinguishable, and in another, I'm not distinguishable. Okay, so these are information. Photons also should be indistinguishable. Therefore, information which is used by these guys in gain medium to produce social lessing, this information should be contentless. Of course, there is no totally contentless information, yeah? But even photons, they have some characteristics. They are not totally identical. Two photons are distinguished by energy, by direction of propagation, by polarization. So there are few characteristics. Up to them, they are indistinguishable. So information field should be structured in this way that majority and these humans, this is process antenna, is human being, and information field, which is emitted by mass media, social networks, by TV, and so on. And information should be reduced to just labels, to some symbolic. So if we get information about some terrible event, we are not really interested in details of this event. It's just very often picture, it's enough picture and so on. So it should be this situation, if you want to have socializing, that people in gain medium are up to some parameters indistinguishable, and their reaction on information is also, they don't go to deep analysis of communications, So this is a scheme. This is scheme of social lasers. So people are considered as social atoms, and this is not just my invention. When I spoke with philosophers, they speak about the same things as I. They even speak about post-humans. Post-humans, those who really lose the characteristics such as religion, nationality, and so on. Creation by mass media powerful information field to pump social energy. Here, first time I put attention, and we even wrote a paper with psychologists about this. The role of information overload. Why people started to process information from mass media, social networks in such contentless way? Why they don't go to deep logical analysis of information? Because nowadays we all are overloaded by information. So very often people follow some lines of news, and this information is going in such huge amounts that they cannot analyze this news. So information overload is a very important condition stimulating social leisure. And now what is also very important, we have powerful social resonators, which are based on internet echo chambers, on internet social networks. So the information emitted by mass media, it does not just go through us and disappear. It goes to social networks, then it is reflected by using comments, posts, and so on, reposting, and so on, coming back to us, and after a few iterations, majority of people can become excited and emit very strong flow of information. Now, further studies, and about A, we have done already something, and I will show you our recent paper. This talk is just, I can say, on the hands, but there are really papers with very deep mathematics and physics. So resonators of social lasers are not the same as physical, because the same comment in social network, it can emit reactions, not typically one photon reflected from mirror is just one photon. The same comment or post can have many reflections. So I started to read this, but I have never did this project. So these should be social lasers, they're even in physics, lasers with active mirrors which not just reflect but generate additional photons. Yeah, and then spin or polarization. So energy exchange is not so simple as I described it. It's not only energy. Spin or polarization is involved. So, and this is because, of course, social science people always ask why some people are excited by this news and others do not. And I think they spin, that we all have some axis, and if this axis is not so far from axis of injected information, you react. If not, you don't react. So I want to stop share, and then I show you our recent paper. Yeah, maybe not this one, just a moment. Our recent paper. Yeah. Where is it? This paper is this? No. I did something bad. Stop share. Так, just a moment. Okay, there is not so much time. I will send to Melvin the references. And this is our recent paper in Scientific Reports. What we studied recently, these social networks, they have the structure of networks. So there is graph. This is graph. So we study social laser, which is not usual physical laser, but laser with very special resonator which has some structure of some neural network, And then there is no theory of physical lasers for such strange resonators. And we started to develop both theory of physical lasers, which are based on not only on optical cavities, on simple optical cavities, but on graph structure of neural network structure of this resonators. And what we found very interesting and supporting thing. We found that laser with social resonator, which is network, is essentially more powerful than usual laser when this just mirrors. And the main parameter, which of course the model is very, very approximate, we use only averages and so on. The main parameter is the connectivity, average connectivity of this network. So if you take some vertex with how many other vertices it is connected. So this parameter kappa, this average connectivity of network, social network or other network, and its scale or quantities of usual physical laser. For example, if you have threshold, how much energy is typically depend on the excitation time of atom, how long somebody can be in the excited state. This is scaled by this. This is scaled by this connectivity. High connectivity, less energy should be pumped into gain media to start social lasing. High connectivity, better coherence of emitted beam of social or physical radiation. And more or less, this is my interest now to connect social laser theory with theory of social networks, and with, for example, the Ising models for this is agent-based models for decisions and so on. And from the point of social laser, what we add to these models, we add information field. So the typical picture is for social structure with Ising model is just these spins, and we add information field, and information field made everything much more effective. So in principle, this is all what I wanted to tell, and thank you very much for your attention. Yeah.